In this exercise, we'll model a spring and check if a 110mm pipe can deliver the spring's flow of 6.5 litres per second. To model a spring, we need two conditions, a fixed flow and zero pressure. We start with the non-spring part of the system already drawn. Node 9 is the spring outlet. From here on, we'll model the spring as a combination of objects to ensure the two conditions mentioned are met. First, we add a reservoir to act as the overflow, absorbing any excess water. Next, we add a node as the spring source and input the spring's flow as a negative demand, -6.5. In EPANET, a negative demand means that water enters the system, but it will do at the pressure the system requires, distorting subsequent pressure readings in the rest of the model. The overflow absorbs these flows to fix the problem. The spring node, overflow, and spring outlet all share the same elevation, 30. We connect the spring node to the rest of the objects. We draw a pipe from the outlet to the overflow. This pipe is a dummy pipe, an imaginary element that doesn't affect results, so we give it a very small length and large diameter. I use 9s to tag these elements. After adding the check valve, we move on to the other dummy pipe. With the spring now ready, we run the simulation. The 110mm pipe can only absorb 4.83 litres per second, leaving 1.67 litres per second to overflow. To improve this, we increase the diameter to 140mm and rerun the model. Now, the full 6.5 litres per second can flow, but we may still be able to install a cheaper pipe. We try a 125mm pipe, 110mm inner diameter. To answer the question we built the model for, no, a 110mm pipe is not sufficient. To deliver the required flow, we need at least a 125mm pipe.